This is what we did. That if you have NPR, choosing with order, this is given by n factorial over n minus r factorial. Do you need this formula if you know how to use a calculator? No. If you do not have a calculator, use this guy. But if you have a calculator that can perform this function, then why memorize this? It can help. The calculator will do everything for you. We also have the NCR, which is given by n factorial over n minus r factorial, and then the r factorial. So that is that. So I think what we want to do now is to take some contextualized problems and some word problems and then see how best we can use these two guys to simplify those situations. So I believe the first 4 questions will help us recap everything we've done. I like those logical problems. Critical thinking problems. So let's start from here. Number 1, what does the symbol exclamation mark represent? Factorial. 4 different people can stand in a line. 4 factorial. Different ways. What is the actual number? It's not me, it's what the question is saying. 24. How do you get 24? 4 times 3 times 2 times 1, that's it. It's as simple as that. We did that. That's what they are supposed to, what do you call it? Exclamation mark. Factorial. California Fantasy. The winning numbers for current California Fantasy Lottery are 13, 18, 22, 24, 32 in any order. Do calculation for winning this lottery involve permutation or combination? Combination. Why no permutation? Because there's no specific order when it comes to this type of lottery. Some of them, though. Is that okay? Let's go to number 3. California Daily 4. The winning numbers for the current California Daily 4 lottery are 5004 in the exact order. Because order count, calculation for this lottery involved either two of the 2 permutation. No, forget about that part. Does this involve permutation or combination? Why? Because order is important. And that is how we get to determine whether to use the P or the C. So that's a good start. 1, 2, 3, 1, 2, 3. Nobody's interested in that. Hey. Let's go. It is? Yeah, the ATM. You want to talk about ATM?
This was horrible.
Oh, no, it's beautiful. It's the same as the license plate. Remember we talked about the license plate? So let's talk about this for a second. A thief. Shh. You don't want me to come after you. Now whatever you're saying has nothing to do with math. A thief steals an ATM card and must randomly guess the correct PIN code that consists of 4 digits from 0 through 9. What must be entered in the correct order? Repetition of digits is allowed. Let's consider the first part first. So in how many ways can we select the 4 digits out of the 10 digits? How many digits do we need? 4. So we have 1, 2, 3, 4. And I believe most of you have ATM cards and the rest, so you have 1. In how many ways can we fill the first part? 10. Because we have 0. And since repetition is allowed, in how many ways can we fill the second part? 10. And this one, followed by, so what do we do with these numbers? Why do we have to multiply them? Because that is the rule. That is the accounting technique rule. So you multiply. So we have 10,000 ways for the thief to try searching your PIN code. And out of the 10,000, how many of them will be the right one? 1. So what is the probability that the thief? 1. Excellent. 1 over 10,000, because of the 10,000 combinations, only one of them represents your PIN code. So the probability that he will get the right one will be 1 out of the 10,000
Or it could be just like 1 over 10.
to the power 4, yeah. What about if there is no repetition? If there is no repetition, in how many ways can this be filled? It's going to be 10. The next one will be 9. You know that, right? Because you are taking out that replacement. 8 and 7. So it reduces.
So then we just multiply 10 times 9 times 8.
Yeah, 9 times 8 times 7. That gives you a smaller number. And the chance of getting that is higher. That is why they allow us to just put the numbers together. Okay, let's talk about lottery. Number 15. Winning the jackpot in Connecticut Classic Lotto requires that you choose 6 different numbers from 1 through 44, and your numbers must match the same 6 numbers that are selected later. The order of the selected numbers does not matter. If you purchase 1 ticket, what is the probability of winning the jackpot? So since it is about probability, the first thing that comes to mind is what? Before combination. Before permutation. If you want to find the probability of something, you have to find the whole, which is the sample space. How do we find the whole? According to this statement. How do we find the number of possibilities of selecting 6 out of the 44? You remember the question, right? I hope you haven't forgotten. It's still on the board. Come on. A tree will not be bad, but it will take us forever. So let's simplify it. Why should we use the P?
So you do the numbers of the event divided by the total?
Not yet. Now you don't even have the number of event. That's what we want to look for now before we think about the probability. It's not conditional probability. You have, do you understand the question? Can somebody break this down for us? No, forget about the probability. Just the first part of the question.
6 numbers out of 53.
This one.
Oh, in Connecticut.
Okay, so now everybody we were all over. Now it's question 15. How are we going to select the 6 out of the 44?
644.
Come again?
Random?
Come on.
Do you do that like the probability?
Before we even think of the probability, we need to do something. Because you know to select 6 numbers out of 44, right? How is it going to be done? Is it going to be the first 6? Is it going to be the last 6? Is it going to be the middle 6? Is it going to be the first, last, middle, da-da-da-da-da? So many combinations. How do we find the number of possibilities?
Do they have to be odd numbers or?
No. We're not told. Where were we?
Like, how to say it?
If the moment I tell you, you're going to say, oh, we knew that.
Say it, that's right.
I won't.
The complements? Okay, so do we just,
They tell you. Pay attention to each word. Don't skip them.
Probability of event.
6 numbers.
Is that what
When you put it in order, you choose like every 6 numbers. That's how I understand.
They have to be 6 different numbers. There's no repetition.
Don't you see the lottery on the television? Some of you even stake them. Don't you do that. No. Is there? It is not there. I'm going to read over. Maybe it will make sense. Winning the jackpot in Connecticut Classic Lotto requires that you choose 6 different numbers from 1 through 44, and your numbers must match the same 6 numbers that are later drawn. The order of the selected numbers does not matter. How do we select the 6 numbers?
Choose 6.
How?
So we have to tell you, right?
Yes.
Alright, so we'll do 1 through 6.
Because I've taught you how to choose stuff.
Alright.
Well, you go from 1 to 44 and you choose a random.
Do we just
I've even talked about that this morning or afternoon.
divided by 6?
And 10
No, it's not that.
We had to count to 6 and get those.
Okay, since nobody's going to tell me because the spring break, I don't know where you went, has taken everything off. Oh, how nice. You wouldn't be here at this time. You would still love it and be enjoying it. I hate this cold weather. All right, so how many numbers do we have?
44.
And we want to choose?
6.
Are we choosing with order or without order? So it's going to be C. Does that make sense?
You just confused me.
I did. She did, right? I didn't even hear that. That was my fault. Then I think I will accept the blame now.
Yeah.
So we choose 6 using combination. So in how many ways can that be done? Calculators. 7 million.
59,000.
59.
9052.
Like that. And out of these combinations, how many of them will be selected by the company? 1. So what's the probability of winning this lottery? 1 out of that.
I can't believe
No, relax. Yes.
For spring break, I went away to the desert, and my aunt told me it rains on average about 10 days out of the year in the desert. I was there for 4 days, and it rained. So I was like, I have to ask, what's the probability of it raining while I'm there? How would I calculate that?
Oh, wow. That's beautiful. Because that's going to be a little bit of conditional probability. It was given that you were there. What if you had not traveled there? Would they have rain?
Maybe she
Yeah,
bring good
but
luck.
you know, like when you're packing, when I was packing, I was like, oh, I'm going to, it's not going to rain. I'm going to bring my shorts and my dresses, you know, and then it rained. It rained for exactly 1 day. I was like,
That's beautiful. But let's think of it from the general point. I may not be able to give you the exact probability. How many days do we have in a year? And of that, if you are told on the average, you get 10 out of that, what would be the probability? 10 over 365. But
any combination. So C.
within the 10 days, that rain in a year, she happened to be there. Right? So we're looking at the possibility that anytime she visits, it will be one of those 10 days. Does that make sense? In that case, the order of her visit does not really matter. The most important thing is it must rain whenever she visits. So it could be you have 10 days and you choose 1 out of it. Because we are not actually interested in when she visits. At least whenever she visits one of them, it's going to rain. But then if the order is important, that on my first visit, it must rain. In that case, there's order. It's going to be P. So it will be fixed, and then you can multiply by that probability. But that is good. I'll think of that. It's going to be one of my questions in the future.
Not for us, right?
Well, no, not for you. For the next one. But that's beautiful. Like, have you even thought of it that way? It's the same as finding the birthday of a friend in a year. You can think of it. It happens once in a month. And once in a year.
Over many of their years of their life.
You can think of it. These are some of the simple things. Probability is almost everywhere. So are we okay with this one?
Yes.
Let's go to the next one. Now don't mess it up. Florida Lottery 16. Winning the jackpot in Florida Lotto requires that you choose 6 different numbers from 1 through 53. Your numbers must match the same numbers that are later drawn. The order of the selected number does not matter,
So it'd be
right? Because order does not matter. And this one can be computed using your calculators. It's a big number. I don't want to go venture, but whatever you get, divide that into 1 and you get your answer. Question 21 is a beautiful question. The Technomill Corporation must appoint a president, chief executive officer, chief operating officer, chief financial officer. It must also appoint a planning committee with 4 different members. There are 12 qualified candidates, and the officers can serve on any of the committees. A. How many different ways can the officers be appointed?
Can you repeat them? No, can you repeat the people into different committees and different,
Can we do that?
can also, yeah.
Why?
Because they say that officers can also serve another.
Everything is there. Whatever you need is provided. So, in how many ways can this be done? Oh, come on, don't be silent on me. How do you know that?
9,
How?
because it's a 3-way when
I wouldn't allow you to continue. Now. In how many ways can you select the...
C4.
How would you know it's 12C4?
Because it's 12 candidates over 4 different members that they want to.
Which of them are you talking about now?
Planning committee with
Are we
4
talking about part
members.
A or part B?
A.
A. How many different ways can this be done? She said it must be 12C4. Is that right? If it's not, why?
It's more than 4 ways.
How do you know? This is not the number of ways.
There's 4 open positions, but you have a CEO and a CEO and a CFO, so that's 7 positions.
Oh no, we don't combine both of them. The company is doing 2 things. First, they are selecting officers. After that, they want to set up a committee. They are not doing everything together. That's why they tell us, hey, suppose you first select the officers. They can also serve on the committee later on.
Oh, be 3 then.
Which one is 3? There's 4. Don't change anything to 3.
Oh, no, so
It is 4.
Oh, okay.
But it is not C.
Oh, it's P.
Why is it P? Where is the order? There is an order. You have to figure it out. Come on, go get it.
Because you have to appoint the CEO and them first, so that they can serve as their...
That is not why.
Oh, that sounds good.
It sounds good, though. It sounds good. It's because this is order. President, chief, excellent. You can tell from there that is order. The president is up there, CEO, chief operating officer, and then the financial controller. That is order. And that is why the first part, which involves the officers, must be 12P4. Because order matters. Because we have 4 positions: president 1, 2, 3, and 4.
Okay, so at least had the numbers right.
Oh, the numbers were right. Does that make sense?
I only see 3 there.
Where is the 3?
The president, chief executive. President doesn't have any parentheses here, that's why. I didn't. Yeah.
Yeah. So now we see the 4. Are we okay with the first part? Okay. Oh, okay. Second part. In how many ways can we form the committee?
So this one would be C.
Why would that be C?
This can be any.
Could be any 4 because who cares who is part of the committee? It's just a committee. Make sure that we have 4 of them. Does that make sense? So now the only challenge here for you is how do I know there's order? That's why I'm giving you all these type of examples, so that when you are somewhere where there's nobody to help you, you don't cry. At least you can convince yourself, I got it. Great. Now let's talk about this. This is the interesting part. Anyway, what is this equal to? Nobody did it? All right, give it to me now. That's going to be 12 times 11 times 10. Like that?
No, 880.
Like that? Okay, what about this one? 495. Is that it? Mm. What is the probability of randomly selecting a committee members and getting 4 youngest of the qualified candidate?
You add both.
No, you can't add both. What is the probability here? You don't need the ages. It's a good point you raise over there. We don't know their ages. How do we know the youngest one? But you don't need them. And why don't we need the ages?
The probability is
Out of 12?
Yeah, 4 out of 12.
4 of the youngest out of 12 qualified candidates.
How do you know how many younger there is?
How do you know that we have the 4 groups? I mean, the 4 within that group.
Because it's order.
Not the order. How do we know we have the 4 youngest? Yeah, it says that. But the question is, we don't know the ages of these 12 guys. We know we have 4 in there. How do we know? No. How do we know that the 4 youngest are together? You do. Did you see the 495? 495 is not just a number. It represents different groups of 4 people. Try to understand the 495 before I continue.
There's 495 different
There are 500 different ways of selecting the 4 people to form that committee. It doesn't make sense? Let me help you out with just a simple example. I need time to talk about project. So Peter, right? Albert, Sabina, who else? Yeah. Ernesto and Trina. 5 people, right? So we have P, A, Sabina, E, and T. So far, so good? I'm going to assign random ages to them. Let's say this guy is 18, this is 15, this is 25, this is 41, 55. Great. Now, out of this, if you are asked to form a committee of 3, follow carefully so you understand the concept. If you are asked to find a committee of 3, how will you go about that? Out of this, not a question, here. How many people do we have?
5.
And we want to find form a committee of 3 members.
5C3.
It's going to be 5C3, right? What is that equal to? Maybe 10. 10. That means that we have 10 different ways of forming the committee. So I'm going to help you visualize these 10 groups, right? So in that case, you can also think of this in that order. First group can be Peter, whoever that guy is, and Sabina. Right? It could also be Peter and that. It could be Peter and this. So far, so good? It could be that is what is going on over there. So this 45 is not just a number, but it's different combinations of the 4. So the next one could be, we can have Peter, S, and E. We can have Peter, S, and T. So far, so good? Yeah. We're going to have Peter, S, Peter, P-E-T. right? Peter, Ernesto, and Trina. Now we can also have ASE, right? AST. We can also have AET. How many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, we were supposed to have 10 of them. 1 is left. SET. Oh, we have SET. So we have, these are the different 10 combinations, right? Of these, do you know that one of them consists of all those young 3 guys? From these ages, look at it. Who are the young 3 guys? 1, 2, and this. PA. That is what the question is talking about. So it's going to be 1 out of 495. No, you said 9. And I wanted to know why. And you say it's in groups of 3. I'm like, stop it there. I hope now you can visualize, right? So that I'm not saying this is easy, but I believe with this example, you can now think about it. Oh, that's what they meant. So even though we don't have the ages, we know that of the 495 of them, one of them consists of all the young guys. Great. So I'll do my last example. No, wait, before I continue. On the test.
When is the test?
I don't know. This is how I will put my question.
That one right there.
Yeah, it's going to be similar to this. Probably without the probability part.
Good.
Because you have a lot of probabilities already on the test.
Is it number 1?
You know here you were told that you have 12 of them? That's pretty easy. I don't give you such stuff. This is what I would do. Instead of telling you I have 12 of them, probably I would say, hey, we have 8 female and 5 male. And we have to form a committee out of that. In that case, what will be the total? 8 female, 5 male. 13. So you must know that your N is 13 because I will not give you the 13. Is that okay? Now let's play around with that so that you'll be all ready for that. 8F, 5 male. In how many ways can you form a committee of 5? 13. Awesome. In how many ways can you form a committee of 5 consisting or composing of only females?
8.
So in this case, we are not interested in the men. That, I'm just giving you this example so that you will think when you are taking the test. It's not going to be straightforward. I'll tweak it a little bit and you have to think. And that's how we think.
Why would you do that?
Because you are smart. Now let's talk about these 2 examples. And with this example, I would be glad if you don't think like educated people. It's very difficult for you to do that. So I'm going to help you not to think as an educated person. We are all dumb,
Yeah, but it's gonna be difficult.
including me.
Our life to think how to
Including me, right? And we're going to think about these questions, right? When you come out with any informative reasoning, I will tell you no, that I will not accept that. But if you come from a layman point of view without knowing anything, then I will tell you, yeah, let's go on with that. Does that make sense? Great. So now let's see what will happen here. Number 30, you want to obtain cash by using ATM machine. But it is dark and you can't see your card when you insert it. Are we good?
Yeah.
The card must be inserted in the front side up and the printed configured so that the beginning of your name enters first. That's why you do it all the time. What is the probability of selecting a random position and inserting the card with the result that the card is inserted correctly?
4 ways.
1 out of 4. Why 1 out of 4?
because the card has 4 sides.
For the card have 4 sides.
You can flip it either way.
You can flip it either way. So far, so good?
Yeah.
So of the 4, only 1 is right. That's why we say 1 out of 4, right? Beautiful. Number 2. What is the probability of randomly selecting the card's position and finding that it is incorrectly selected on the first attempt? Inserted, thank you. But correctly inserted on the second attempt.
1 out of 2.
1 out of 2.
Which one is the 1 out of 2? It was, how many times did the guy try it?
4 times.
Twice. The first time it was incorrectly inserted. What is the probability of inserting that incorrectly?
2 out of 4.
Why 3 out of 4?
Because you've already used 1 try.
No, that's not why.
3 out of 4
Because there's only
because,
one time you can get it
he
right.
got it once and got 3.
3, excellent. Because the card can be inserted, as you said, in 4 different ways, right? And of them, only 1 is right. That means 3 of them, not good. You may have to take out your card and try it again. Oh, think about it. A card. This is your card. It doesn't work. It doesn't work. You flip it. Doesn't work. It works. So 3 different ways, not working. 3 out of 4. But then we are told that on the second attempt it works. So what would be the probability for that?
1 out of 4.
1 out of 4. You still have the same card. And then you multiply. But the most interesting part is the third part.
Minus.
How many, this is no probability, how many random selections are required to be absolutely sure that the card works because it is inserted correctly?
4 out of 4.
No.
4 times, right?
Now you are using informative reasoning. This is when I don't want you to think about what you know.
How many? Well, if you insert it 3 times wrong, and then the last time you get it right,
It's just 1
that's
time.
4 times. I don't know. For some reason, I want to say 8 because I would try it again and be like, oh,
But then
does it matter?
It does matter.
The ATM eats the cards after a certain number.
3 times.
Yes, 4 times.
Because you can only have 3 times that it would be wrong. On the 4th time, it's going to be right.
Remember, it's still dark at the, I hope you haven't forgotten that, right? It's dark. Let's assume your card even falls down. How would you know which direction is in there?
So to be absolutely sure, I think it's
Now you are using informative reasoning. She's saying, why don't you fill the card? And that is reasoning. We don't want to use that.
I think it's
It's not 3 times.
2 out of 4.
No, it's not probability.
1.
Once?
You're not gonna notice if it falls.
You're never going to know. Let me prove it to you now. Now you think, now because you are smart, you think that's the way it's supposed to work. Have you ever been to an ATM machine? Somebody in front of you, it takes the person forever to deposit or withdraw money. And you'll be there. Then it feels soon you start tapping. And then you start from your own. Get out of the way. You'll still be there. Some people can insert the same card in the same way as they did. It go, quack, quack. What's going on? Quack, quack. Come on, get out. We want to go to work. If you haven't had one before, I pray that someday you meet somebody like that. You leave the ATM machine with your money, but you are not satisfied. Because the person in front of you has messed up your whole day. So this is just to tell you how we have to accommodate some people, even when there is light. Because they stand in the light, and it will take them forever to be done. And you wonder what they will be doing. No, that's not good.
So it's infinite?
It's infinite. It could be 1, it could be 2, it could be 3, it could go on. You can
C
stand.
would be infinite, that's it.
That's it. Different ways. So, but because you are educated, even when there's darkness, you can take your card and feel it. That is informative. That's why I asked you to forget about all those things. Great. My last example. 23. Good. Combination lock. The typical combination lock uses 3 numbers between 0 and 49. and they must be selected in the correct sequence. How many different combinations are possible? Which of the 5 rules? I'm not even interested in that. I'm interested in the last part. Is the name combination lock appropriate? Why? If it's order, what name should we give it to it? Permutation. Stop calling it combination. When you hear somebody say tell him it's not combination. It's permutation lock. Because the order matters. Because some of you can even spend forever in front of your lockers trying to get the numbers right. Come on, what is going on? So funny. So it must be permutation, not combination lock, because the order matters. If it's 1, 2, 3 and decide to do 1, 2, 1, 4, 3, you can spend forever in front of your locker. And we can even call the police. That guy is stealing something from his locker. Great. Awesome. So that is the summary of the permutation and combination. Now, what I would like you to do your homework so that you can test yourself to see, do I really understand permutation and combination?
Done today.
Well, I'm going to give you an extension on that.
I do have a question about homework.
Mm-hmm.
One exercise in particular.
Mm-hmm.
That is, I wrote it down.
That is if I can talk about it.
The number 23.
What does it say? Yeah, read it. If I have to.
Yeah, we just did it. That was
The one with
Oh, we did that?
Yeah, we did it.
the first. Yeah, that was the C. That was the C combination.
That was
part.
the C combination.
You see, I don't even know. So, yay, we done that. Great. Now let's talk about project. Project starts now.